This is the Unit 4 Assessment Review, voiceover. Starting on number 1, it says, here is a balanced hanger diagram. A triangle has a mass of 4 grams, and a circle has a mass of 2.5 grams. What's the mass of a square? Show how you reached your answer. So let's fill in. Look at our hanger here. They're balanced. So what we need to do is identify each of the triangles as 4 grams. So we have 4, 4, 4, 4, 4, 4, and all of our triangles on both sides are 4. Now let's do our circles. Our circles are 2.5 or 2.5. Find our circles, 2.5, 2.5. And on our other side, 2.5, 2.5. And then what we need to find out is what's the mass of 1 square, of a square. So that's going to be our x values. I'm going to put an x by each one of our squares that we don't know. So what I'm going to do is use this information. I want to create an equation to solve for x, what 1 square would be. So what we need to do on this is I want to try and clean everything up real good. So I'm only going to look at the left side. So here's our equal sign. On the left side, I'm going to count how many x's we have. We have 1x, 2x, just 2 x's. So we have 2x. I'm going to write that here. And we have plus. Now I'm going to clean up the rest here. So we have 1, 2, 3, 4, 5, 6. 6 times 4 is 24. So I'm going to put plus 24. Plus. And then 2.5 plus 2.5 is 5. Plus 5. All right, we really cleaned that up. There's more we can clean up. I know we can clean this up further, so it'll be 2x stays the same, but I can add 24 plus 5 is 29. Now let's do the other side. I'm going to start with my x's. I have 1, 2, 3, 4 x's. So I'm going to write 4x plus, and then we have 2.5 plus 2.5 is 5, plus 4 plus 4 is 8. So I'm going to clean this up. 8 plus 5 is 13, so it'll be 4x plus 13. All right, now we're getting closer. So first thing we need to do is get our x's to one side. And what I do is when I'm looking at an equation, I always pick the smaller of the two. And you can move either one, but I always think it's easier to move my smaller one, then I don't use negatives as much. So I'm going to get rid of this by subtracting 2x. When I do to one side of the equal sign, I have to do the other. I'm going to put it underneath the like term. So 2x minus 2x is gone, that's 0. So all we have left is 29 on the left side. On the right side, we have 4 minus 2x, which would be 2x. And we still have this 13, plus 13. All right, now we just have a two-step equation. I want to get x alone. I want to get rid of either my add, subtract first. In this case, we're adding, so to get rid of it, we do the opposite. We have to undo it, so we're going to subtract 13 from both sides. When I do to one side, we do the other. So 13s are gone on the right, so all we have left is 2x. And 29 minus 13 is 16. And our last step, this says 2 times what number? Well, the opposite of times is multiply. The opposite of multiply is divide. We're going to divide by 2 on both sides. What we do on one side, we do the other. So our x will equal 16 divided by 2 is 8. So our answer is 8 grams. Moving on to number 2. In this section, we have 6 different problems. It says solve each equation solve each equation below. Show your work or explain your reasoning. Be sure to check your solutions. So in the first one, on number 2, let's look at it. I'm going to zoom in so it's easier for you to see what I'm doing. So we have 1/2 x minus 7 equals 1/3 times the quantity of x minus 12. So the first thing I'm going to do is I'm going to look to see if there's anything I can combine. I can't do anything on the left side of the equal sign, but the right side I can clean up a little bit. So I'm going to distribute. So I'm going to keep 1/2 x the same. Minus 7 stays the same. 1/3 times x is 1/3 x. 1/3 minus, I'll put a minus sign, 1/3 minus times a negative 12, which would be a negative 4, or minus 4. Now what we're looking at is we need to get x's to one side. But you can see that we have unlike denominators. They're both different. We have a 2 and a 3. So I just want to clean that up. So what I'm going to do is I'm going to multiply by 6 because 2 goes into 6 and 3 goes into 6. So I'm going to multiply all terms by 6. So 6 times 1/2 is 3. We still have x, so 3x. 6 times negative 7 is minus 42. 6 times 1/3 is 2x. And 6, I'll put a minus sign, 6 times 4 is 24. So we have minus 24. Now it's much easier to work with. We got rid of our fractions, just like that. So I'm going to look to move my x's to one side. I want to move my smaller one, 2 smaller than 3. So I'm going to subtract 2x. Subtract 2x. So this is 1x, or just x. So we have x minus 42 equals negative 24. My last step in this case, I'm going to add 42. Add 42. I'm out of room. 42's cancel out. X will equal negative 24 plus 42 is 18. Positive 18. So, zoom that out just a little bit. Now our next step, let's check to see if we're to verify. So right up here. What we're going to do is we're going to use our original equation, and we're going to substitute 18 in to see if it works out. So it's going to be 1/2 times x. Our x is 18, so that's times 18, minus 7 equals 1/3 times our x, which is 18, minus 12. All right, so now let's figure this out. Well, half of 18, 1/2 times 18 is 9. 9 minus 7 is 2. So we have 2 on the left side. I'm going to, since we have parentheses, I'm going to go 18 minus 12, which is 6. So 1/3 times 6, 1/3 times 6 is 2. So 2 equals 2. Yes, it works out. So we know x equals 18. We just proved it. Moving over to the second one. 6 times the quantity of 4x plus 12 equals 8 times the quantity of 3x minus 14. So we got to clean up both sides by doing the distribution method. I'm going to make my rainbows. 6 times 4 is 24x. 6, put the plus sign, 6 times 12 is 72. 8 times 3x, 8 times 3x is 24x. Minus sign. 8 times 14 is 112. I want to get x's alone, so we have 24x and 24x. Doesn't matter which one we do. We want to move this one, so subtract 24x minus 24x. 24x cancels out on the left, 24x cancels on the right. All we have left is this 72 equals negative 112. We have to ask ourselves, is this a true statement? Is 72 ever equal to negative 112? Absolutely not. So we'd say no is solution. Third one. Here. So we have 1/2 times the quantity of 10 plus 12n equals 1/3 times the quantity of 15n plus 15. So I need to distribute, and really I'll do my arrows underneath it, even though there's not a lot of room. So 1/2 times 10 is 5, plus 1/2 times 12 is 6, and we still have an n with it. We're down on the left side. 1/3 times 15 is 5, we have an n, 5n, plus 1/3 times 15 is 5. So this time I'm going to get my n's alone, or to one side. I'm going to move my 5n because it's smaller, so I'm going to subtract 5n to make it 0. When I do to one side, we do to the other. It helps put this bar in. It separates it. So on the right side, all we have left is 5. 6n minus 5n is n. So we have 5 plus n. I want to get n by itself, so I need to get rid of this 5. So I want to subtract 5 to make it 0. What I do to one side, I do to the other. You're going to notice it becomes 0 on both sides. So n will equal 0 in this case. So this one we have to check to see if it works out. So I'm going to substitute 0 into our equation here. So it's 1/2 times 10 plus 12 times n. N is 0, so I'll put 0 in. Equals 1/3 times 15 times 0 plus 15. All right, so let's do everything in parentheses first. 12 times 0 is 0. So we have 1/2 times 10 is 5. 15 times 0 is 0. So all we have left is 15 in parentheses. 1/3 times 15 is 5. So yes, 0 works. Moving to our fourth one. This one says 8 times the quantity of 2x minus 3. Then we have minus x equals 3 times the quantity of 3x plus 2. So we have a few things going on. We have to clean up on both the left and the right-hand side. I'm going to distribute on the left first. So 8 times 2x is 16x. 8, I'll put a minus sign. 8 times 3 is 24. And then we have this minus x. And I'm just going to distribute on the right side. 3 times 3x is 9x. Plus 3 times 2 is 6. I want to clean up my left side. I want to combine like terms. We have x, 16x minus x is 15x. We still have minus 24 equals 9x plus 6. There's nothing I can do on the right-hand side. So we're going to move our x's. I'm going to move my 9x is smaller than 15. Subtract 9x, subtract 9x. So we get 6x minus 24 equals 6. I want to get x alone, so I want to get rid of this minus 24, so I'm going to add 24 to both sides. 24 is gone. I'm running out of room, so I'm going to write it over here. So all we have left is a 6x equals 6 plus 24 is 30. Divide by 6, find what x is. X will equal 5. So we need to check this one. So we're going to plug in all our x's with 5. So it's going to be 8 times the quantity of 2 times x. Our x is 5, so 2 times x minus 3. Then we have this minus x, which is 5, equals 3 times 5. That's our x plus 2. So let's clean up inside our parentheses first. So it's going to be 8 times 5 times 2 is 10. 10 minus 3 is 7. And we have this minus 5. On this side, we have 3 times 5 is 15 plus 2 more 17. So we have 3 times 17. So this one, 8 times 7 is 56 minus 5. So we have 51. On this side, we have 3 times 17, which is 51. 51 equals 51, so yes, it works out that x equals 5. The last two, back over. So this one we have 16x plus 24 equals 8 times the quantity of 2x plus 3. So there's nothing we can do on the left-hand side. I can't combine like terms, there's no distribution, so I'm just going to write it up. Carry it down. 16x plus 24. This one we can distribute. 8 times 2x is 16x plus 8 times 3 is 24. Now I need to move my x's. It's on the same side. So I'm going to move 16x. They both are 16x. You're going to notice they both cancel out. They both become 0. So all we have left is 24 equals 24. Is that a true statement? Absolutely. Yes. So our answer would be infinite number of solutions. So if we notice our x's cancel out, Now we have left our constants, and our constants were both the same, they're equal. It's a true statement, so it is infinite number of solutions. Moving over to our last one on this page, we have negative 3x plus 13. There's nothing we can do on this side. On the right side, we can distribute 3 times quantity 4 minus x, and then we have this plus 1 at the end. So 3 times 4 is 12, minus 3 times x is 3x, and I still have this plus 1. So I'm going to clean this up a little bit. I can combine on the right-hand side. So on the left side, it stays the same. Negative 3x plus 13 equals 12 plus 1. I'm going to say that's 13. And I still have this minus 3x. I want to move my x's. Doesn't matter. They're both negative 3x. So I want to add 3x. When I do it to one side, we do the other. You're going to notice that our x's cancel. They become 0. So we have 13 equals 13. And once again, same answers like before. Infinite number of solutions would be our answer. Moving to our next page. Zoom out a little bit. So on our next page, it's saying, solve the following system by graphing. So we have 2 different linear equations here. So there's a few things that we need to review before we're able to do this. And so we have y equals 2x minus 4, and y equals negative 1/3 x plus 3. So what we should review on this first is slope-intercept form. So we have y equals mx plus b, where m, the number that's with by our x there, the coefficient, this is our slope. And what slope is, it's our vertical distance over our horizontal distance. That's telling us, well, we're going to go up and over or down and over, depending on what direction we're going. Our b, I'll zoom in so you can see what I'm doing. Our b, our back number here, this is where the line, crosses the y-axis. So if we're looking at our graph, this would be our y-axis, right there. The line is going to cross right at that point, wherever our back number is, that b. It's just going to be, we call it a constant. It's a number that does not have a variable with it. A variable is a letter. All right, another thing that we should review a little bit, Mr. Slope Guy, if it's a positive slope, it's going to be going uphill. If it's going downhill, it's going to be a negative slope. If it's straight up and down, it's going to be undefined. If it's horizontal, it's going to be 0 slope. So we have Mr. Slope Guy. Kind of help us with that. So what I'm going to do is I'm going to write out both equations, and we're going to identify our m and b for each one. So our first one is y equals 2x minus 4. We're going to identify our m and our b, and then we're going to do it again for our other equation. So our m, if we look at our equation, our m is our coefficient of x. So in this case, it's 2. It's a positive 2. So if it helps you with your slope, think of, since slope is a vertical distance over horizontal distance, it's like a fraction. Is a whole number. If it helps, you put a 1 underneath it. But you don't need to. As long as you remember that it does, every whole number has a 1 underneath it. And then our back number. We look at our back number, our b, that's where it's going to cross our y-intercept. In this case, we always look at the sign with it. In this case, it's negative 4, so I'll put minus 4. So let's graph this one. So we're going to be using our m and our b. So the very first thing we look at is our b. I think of b as beginning. So it's going to cross our y-axis at negative 4. So here's our origin. That's 0, right where my pencil is. It's going to go down to negative 4. So 1, 2, 3, 4. We're going to put a dot right there. That's where our line crosses our y-axis. We're going to go right off that dot. We're not going to go anywhere else on this coordinate grid. We're starting from here. Now we're going to look at our slope. Our slope is 2 over 1, positive 2 over 1. It's a positive slope. It's going to go uphill, like Mr. Slope Guy. So that tells us we're going to go vertically 2, 1, 2, and horizontally 1. We want to go up 2, over 1. That's enough dots. And here would be our line. And it goes forever in both directions. Our next equation, I'll zoom in a little bit. Next equation is y equals negative 1/3 x plus 3. So our m is negative 1/3. That's with our coefficient. Our 1/3 is our coefficient of the x. Make sure you note it's negative. And our b is positive 3. So we're going to use that to help us graph. So looking at our origin, our beginning point is positive 3. So I'm going to go up 3. 1, 2, 3. Now from that point, we're looking at our slope of negative 1/3. So that means, and I want it to intersect over here. Because our answer, our solution is, where do these intersect? It's going to be an ordered pair. Our x value and our y value. And we'll plug those in shortly. So from positive 3, I'm going to use the slope, a vertical distance of 1. So I'm going to go down 1. And it has to be going downhill because it's a negative slope. So down 1 and to the right 3. 1, 2, 3. And this is where, my line's a little bit off, the intersection point would land. So what would that be as a ordered pair? So we're going over, starting at our origin, 1, 2, 3, and then up 2. So 3, 2. That's how we write that. 3, 2. And that is our answer. So I'm going to draw that line in. And it goes infinity both directions. Next one. Okay, in number 4, it says Ellie and Calvin are both saving for a new iPad. Ellie started her account with $75 and then put in $10 per week. So I want to underline a few things. So we have Ellie. She started with $75, and then she adds $10 a week. Then we have Calvin. He starts at $50 and adds $15 per week. So in letter A of number 4, it says write a system of equations that represent the situation. So we're going to let x equal the number of weeks and y equal the total amount of money. So let's do Ellie first. So we have the total number of money, total amount of money. And Ellie, let's look. So she started with $75. So I'm going to put 75. Plus, she's going to put in an additional $10 per week. 10x. Because every week, we're adding $10 to it. So there's our equation for Ellie. Calvin. Calvin started with, so we're going to put total amount again, y equals, he started with 50, and then he adds $15 per week. So 15x. So that's our system of equations. We're going to look at those two equations. So in letter B, it's asking us, after 3 weeks, who has more money in their savings account? And explain how you know. So let's use Ellie first. We're going to use Ellie's equation. And here's our equation. Y equals 75 plus 10 times x. Our x in this case, they want to know at 3 weeks. So I'm going to put a 3 in, where x would be. So let's solve this. Y will equal 75 plus 10 times 3 is 30. 75 plus 30 is 105. So after 3 weeks, Ellie's going to have $105. Okay. Just do the same thing, but I use Calvin's equation. This time, Calvin is y equals 50 plus 15x. But instead of x, I'm going to put times 3, because we want to know how much money he's going to have after 3 weeks. So, y equals 50 stays the same. 15 times 3 is 45. 50 plus 45 is 95. So y equals $95. So who has more money? Ellie. Ellie has more money. Has more. Oh, let's zoom out a little bit. More money after 3 weeks. Letter C. Letter C reads, after how many weeks will Ellie and Calvin have the same amount of money saved? Same should tell you we need to set this equal to one another. So we have to find out how many weeks, that's the first part, then the next part, how much money will that be? We have to show our work. So here we go. What we're going to do is look at our system of equation. We're going to set these equal to one another. So this is what it's going to look like. So our Ellie's was 75 plus 10x, and we're going to set that equal to Calvin's of 50 plus 15x. Because we want to know when they have the exact same amount of money. So there's the two system equations. We're putting them equal to one another. So I want to just solve like we did in past problems. So I want to subtract 10x because it's smaller than 15x. So what I do to one side, I do the other. 10x is gone, so all we have left is 75 equals. There's nothing I can do with the 50. 15 minus 10x is 5x plus 5x. I need to get x alone, so I need to get rid of this 50 and the 5, so I want to get rid of the 50 first. Subtract 50 to both sides. What I do to one side, I do the other. 75 minus 50 is 25. And then we have equals 5x. I'm going to get x alone, so the last step is divide. 25 divided by 5. So x will equal 5. So it's going to be 5 weeks. That's when they're going to have the same exact number of how much, they'll have the same amount of money at 5 weeks. So now they want to know, well, how much money will they have at 5 weeks? So there's two ways you can find this answer out. You can use Ellie's equation or Kelvin's equation. You're going to get the same exact answer because we set them equal to one another. So let's do both. So this is Ellie first. Ellie's equation was 75 plus 10 times x. In this case, we're using 5 for our x. 75 plus 10 times 5 is 50. So it's $125. So that's the answer. How much money will they have when they have identical amounts of money, which is at week 5? And let's test out, in case you did Calvin's. Calvin's equation was 50 plus 15x, but instead of x, I'm going to put 5 because we figured out they're going to be matching the amount of money at 5. So 50 plus 15 times 5 is 75, so 50 plus 75 is 125. Notice they're the same, so either one of these would work. All right, on our next problem, we're going to stop there and I will pick up recording